Yeah, so till now we completed Terraform infrastructure part. So infrastructure is nothing but preparing the base. Okay, if you think about a state or country, so as I said earlier, for example, if your state infrastructure, country infrastructure is the road connectivity, transport, airport connectivity, ports, and the resources, water, electricity. So these are all part of infrastructure. So if infrastructure is good, then you will get the companies and business, ease of doing business, everything will happen. So if infrastructure itself is not there, then you cannot do anything. Companies will definitely not come to your state or country. So that is the overall idea, right? Similarly, if you want applications to be deployed, then you should have the infrastructure ready. So that's what we were doing till now. So Terraform, what we did, we created VPC, database, security groups. So all those things we were creating. So we have another infrastructure like EKS, load balancers, everything, but the procedure of creating infrastructure is same. Okay, so that is the one. Now it is time to discuss about application part. Okay, so if you think in Terraform is a infrastructure of your country, applications is like you are attracting the business. So if infrastructure is there properly, then applications will not face any problem. Okay, otherwise deploying the applications will be very difficult. That is my point, original point actually. So now before discussing Docker and Kubernetes, so I want to discuss a simple real life example. Okay, just think it as a story. Just don't think of anything right now. Okay, not related to any IT. Don't think of any IT terms. Let's discuss a simple story. Okay, so I want to discuss some difference between individual house versus flat versus a single room. Okay, so now let us discuss the advantages and disadvantages. So basically, you need some area to live properly. Sometimes you need a house with your family, or sometimes you need to stay yourself. Okay, if you are a bachelor. So let us discuss about individual house now. So what are the advantages of individual house? Complete place is yours. Complete place is yours. And then independent. Okay, this is independent. So those are the disadvantages. And what are the, so those are the advantages. What are the disadvantages? So disadvantages, or can someone please type in the chat also? You need to manage yourself completely. Okay. Here you have privacy as well. So water connection, you need to bring. And then electricity, you need to worry about it. Security also completely yours. You have to manage the security. Okay, so these are the advantages and disadvantages. And you need to do the construction by yourself. Complete construction you have to do. Okay, so this is the individual house. If you take any flat, what are the advantages here? Less cost. And here one more disadvantages is high cost. Okay, so what are the advantages of flat? So this construction time is, you can say, 6 months. 6 months, one house. Okay, here the construction time is, for example, if you take a small apartment also, 30 houses maximum 2 years. So one flat around 2.5 months, right? So here one living house is taking 2.5 months. Here the house is taking 6 months. Construction time is very less. Cost is also less. And security, you can have common security. And what are the advantages here? And you no need to worry about water connection. Everything can be provided, and electricity connection. Okay. So disadvantages is no privacy, common area. Okay, so these are the disadvantages. No. So now let us think. You are not a family. You are moving from. You are a bachelor. You got a job in Bangalore. You are moving from your native place to Bangalore to do a job. So in these two options, you don't feel anything is flexible for you. Okay, because here you need to pay high rent and more advance, and this much big area is not required for you. So then obviously what you do, you will search some pages like Nest Away. So here the advantages are there for you, more advantages as a bachelor. So that is like what you can say, easy to move. Okay, and less, very less price. Easy to vacate also. Here, considering the cost, you need to pay high rents. Actually, at least for construction, you need to pay high amount, high investment. But here, there is no much investment. As a bachelor, you are not willing to buy a flat to stay. You are not willing to construct an independent house. You want everything in a flexible manner. Easy to move, very less price, easy to vacate. Okay. And here, the disadvantages are common kitchen. For example, we have some people, they have a triple bedroom flat and they will give one room to each person. Okay, so everybody have their own bedroom and washroom, but they have common kitchen, common hall or living room. Okay, so these are the disadvantages, you can say. But as a bachelor, you can feel these are the advantages also, so that you can cook, you can have some living room option, everything is available here. So this is more into flexibility as a bachelor or as a single person. Whenever you want, you will stay. Whenever you don't want, you will vacate, and you can easily move to the other place. This is more about the flexibility. So these are the three options as a person you have. So if you are a family, definitely you don't. If you are a family, definitely you don't prefer this one because you are not a single person. You are like a couple and two kids. So definitely you will prefer flat or individual house. So in these two options, if you are a family, based on your budget, based on your property, based on your earnings, either you prefer flat or you prefer individual houses. If you are a middle class person, then definitely you prefer flat because of less cost. Okay, and you don't need to worry about security, water connection, electric connection. If you are a very rich person, okay, and then you have crores of income monthly, then definitely you will prefer individual house. Okay, so here if you say within the house you have some infrastructure as a water, electricity, and then you have some bedroom, all those things, right? So similarly, applications, let us think about the applications. Okay, so home, either individual or flat or Nest Away PG. So this is for a purpose of living plus staying, cooking. So this place you want. So similarly, applications, if you want to deploy an application, you need a server or laptop. For example, you have your laptop and it should need some OS. Okay, So for living, what else you need? Like water, electricity, all those basic things you need, right? Similarly, for applications to be up and running in servers or laptops, first you need either server or laptop, and inside that there should be a OS running. So including OS, you should have some packages installed. Okay, just compare these things with this one. Server and laptop is nothing but house. So inside house, you need some basic amenities like paintings and then some plastering, all those things, and few packages like you should have some woodwork and some cupboards, ACs, all those things. Okay, so similarly, applications also need a server should be running and a OS, and then a packages, minimum packages should be installed. And then on top of that, application server like Tomcat or Nginx. So if you have all these things available, then you can install application on top of these. Okay, just compare these things with your individual flat or normal flat nested by PG. You should have some basic facilities of some area plus basic facilities of water, electricity, AC, and then you should have some paintings, all those things. So these are the basic things for application to run. First of all, you should have either a server, and it should have some OS like Linux or Windows Server, whatever, and it should have some packages installed. On top of that, application server like Tomcat or Nginx, JBoss, WebLogic, many things, and you should install your application on top of this. Then this is like complete suite. Okay. So similarly, like this, we have some earlier we had some infrastructure that is like on-premise servers. Okay, on-premise servers means, so you will have a data center. For example, you have a data center. Like earlier, every company has their own data center. So in that data center, you have server and you need to install OS and provide networking power to them, some space. Okay, all those things you need to do for on-premise servers. So if you have this one ready, then on top of this, you install packages and application server and your application. Okay, so to run a single website, first of all, you need to buy the server and install OS, provide power, networking, space, security, and everything on your own. Then you need to install your application. So this is like an individual house. Everything should be managed by yourself. Okay. A single server. For example, server you bought like 64 GB RAM and then 1 TB hard disk and some processor. So what are the disadvantages here? Maybe your application requires only 10 GB RAM and 20 GB hard disk. Okay. So then what about the remaining things? Everything is like wastage, right? Okay. So resource utilization is very poor here. Resource utilization is very poor. And more installations is required. So this is what everyone was doing in late early 2000s. Okay, everybody was having their own server, everybody has their OS team, networking, and some security, some power management team. Everybody was doing like this on-premise servers. So then they understood this is more of wastage, we cannot go with this. Okay, so let us use the resources properly. Then they went into some revolutionary concept, virtualization. Okay, so virtualization is nothing but just like your individual house and a flat. if you have suppose some area, you can build only one individual house. But if you convert it into an apartment in the same area, you can build like 5 floors, 6 floors, 10 floors based on the government permission. And in the same area, you can build like 20, 30 flats. Okay, that is the resource utilization of the space. So similarly, having a single server, a big server doing a lot of wastage, virtualization concept is logically dividing a single server into multiple servers. Okay, for example, here you have 64 GB RAM and you have 1 TB hard disk. Okay, so you have a big server of your company. So then everybody, like there will be 4 teams. Okay, so then what you can do, each team you can allocate 8 GB RAM and then 50 GB hard disk. Okay, so you can create, like for example, four logical servers. So this is the virtualization. So this was a revolutionary concept in 2000, late 2000s. Okay, so you have Oracle Virtual VMware software. If you install it in your Windows laptop, you can create Ubuntu servers within your Windows. So that is the virtualization. You are logically dividing your laptop into multiple servers of Windows, Ubuntu, CentOS, like that. So now companies, they got huge advantage because they will buy a big server and then they can do the resource utilization properly, and cost is also very much reduced. Yeah, it is same like hypervisor. So virtualization is nothing but hypervisor. Okay, so this is the virtualization concept, and everything was good. The only disadvantage here is you need to learn virtualization. You need to have a separate team for virtualization. Okay, so now this also we felt like 8 GB RAM you are applying for one server, right? 8 GB RAM you are dividing for one server. So out of this 8 GB, so applications may use maximum 4 GB RAM only. Okay, so because you always keep some extra RAM for applications to run properly, and out of this they may only use 20 GB hard disk only. But still this is completely blocked by your server. So here resource utilization is also very less. So apart from resource utilization, so we will have some parameters like, yeah, okay, anyhow, I'll discuss those parameters. So here the resources are blocked up to, if they allocate 8 GB to your project, if your server is using only 4 GB, then remaining 4 GB is also considered as wastage. But compared to this previous on-premise server, this is somehow good. And let us take about the installation. Here, if something happens to your server, like then the entire application is crashed. Entire app is crashed if something wrong happens. And what is the bootable time? So you need to buy a server. If you want to add another server to your data center, you need to buy server, install OS, set networking, power, space. So the bootable time is very, very high. Bootable is nothing but the server should come into the usage. So then the time is very high. Usually in 2000s, it will take a month, at least month of time, because you need to raise a request. So your manager, your management should approve the request. You need to order a server, then OS install, provide networking. So this procedure will take at least a month if you want an extra server. But here inside virtualization, it will take within minutes, like 5 to 10 minutes to create another virtual server, install OS. The bootable time is very less, 5 to 10 minutes. To create another logical server and come install OS, all those things. Okay, here bootable time is very less. And now let us think of something called containerization. So now everybody is talking about containerization. Why they are talking about containerization is nothing but just compare this with the PG, okay, the flexibility. Okay, easy to move, very, very less price, easy to vacate, all those things. Now, here the major advantage is 4 GB RAM, 8 GB RAM is already blocked. Okay, either you use it or not. But here, there will be no hypervisor. Okay, so to say that properly, okay, let me take the draw.io. So just understand this, okay? This is very important to understand. So let us take this as a server. Okay, so out of this, you will have hardware, on-premise server. Okay, so this is a hardware, and on top of this hardware, you install OS. On top of this OS, you will install some packages. And then you will install application server. And finally, application. Okay, so this is the flow of your application should be running. Okay, so this is the server. But similarly, if you take hypervisor like virtualization, on top of this hardware and OS, so this is called as guest OS. There will be another layer that is hypervisor. Okay, so this hypervisor is, then it will create multiple servers, for example. And I can show you hypervisor versus on-premise. Okay, so like this. On-premise versus virtualization. Okay, so like this. So you will have your hardware on top of operating system. You will have some hypervisor. On top of this, you can have your logical servers. Those are called as virtual machines. Okay. And when it comes to container, there will be no hypervisor. Okay. So you will have hardware and then OS and hardware and OS. Then here container or image is called as base OS plus required packages plus application server plus application code. Okay. So you will mix all these things and create image or container. Then you will run this container inside the server. Okay. So like this, on top of operating system, instead of hypervisor, you will have the container engine like Docker software. Okay. And if you run this image or container, so they will get a question, what is Docker image or Docker container? What is image or container? Image or container is a suite of base OS plus required packages plus application server and application code. Then you will run this on top of the container engine. Then you will get your application up and running within seconds. Okay. So just like Nesta Web PG, it is very easy for you to join into the PG and to vacate the PG. It is very easy to run this container or image as applications within your server. Okay, so this will take seconds and it will not block storage. Okay, so you no need to allocate 8 GB and 50 GB hard disk to it. It can take based on the usage. If it is using less resources, then it will take less memory. If it is using more resources, then it will take more memory. So basically, it will not block the storage. Proper resource utilization is there here. And bootable time is very less. Okay. So this is the advantage. So now let us discuss. So till here, any doubts to you? Base OS is nothing but just an OS again. So in as part of virtualization, I discussed like you will have guest OS, right? So instead of guest OS, here it is just base OS. So any doubts still here? Okay. So now let us discuss the advantages and disadvantages of this approach. So points is bootable time. This is the main thing. For example, tomorrow you are running an Amazon business. Tomorrow you are announcing Big Billion Day. So your traffic cannot be expected. So like you seen a few months back, so when there was a Prabhas interview in AHA, so the complete OTT itself is crashed because we cannot expect the traffic. So if you have some Big Billion Day tomorrow, your traffic can be 100 times more. If you follow this on-premise approach, okay, so then it is very hard for you to plan. You should 1 month back itself, you should be ready for this approach. You need to order lot of servers, install OS, provide networking space, everything. Okay, and you need to be ready with your application. In case of virtualization also, it is same. Okay, You will allocate some memories to the servers, and they will take 5 to 10 minutes. Within that 5 to 10 minutes, your application itself will crash because you will get lakhs and crores, millions of requests to your server. But here, bootable time is within the seconds. Okay, so then it can serve the sudden spike in traffic. Okay. That is bootable time. Cost is very, very less. And then resource utilization is more. High availability is more, because in terms of containerization and Kubernetes infrastructure, you will have multiple servers. Okay, if one server is going down, if one server goes down, immediately app will be shifted to another server. Okay, so this is the high availability. For example, you are staying in a PG. If suddenly your PG, if they ask you to vacate the PG, immediately you can shift to the another PG within a day. Okay, so that is the high availability. Here also same. There will be multiple servers. If suddenly one server is crashed, then your application will be shifted to the another server immediately. But in terms of virtualization, you cannot. If a server is crashed, then the entire virtualization will go down. Okay, all the servers within this virtualization server will go down. But here, application will be immediately shifted. Auto scaling. Based on the traffic, your application instances will be increased within seconds. Okay, suddenly if you get more traffic, then one instance of your application is not enough. Then Kubernetes or Docker orchestration can create multiple applications within seconds. Okay, and reliability. Reliability is nothing but trust on application. Here trust is very high, as I said, because the application will be, if server goes down, the application can be immediately transferred to the another server. So you can blindly trust this containerization process. At any point of time, your application will not go down. So that is called as reliability. And very, very important point, that is consistent environment. Okay, so consistent environment is nothing but, this universal problem, working in dev, not working in production. Okay, this is the universal problem in softwares. So when you are developing something, it will work in your laptop, it will work in your development servers. When you shift that application to production, suddenly it will stop working. Then you need to, your business will go down. Then you need to analyze what is the difference between dev and production environment. The difference is, development servers usually will be very careless in development servers. There will be one OS version. And in production servers, there will be different OS versions. Okay, different OS versions, different package versions. Development servers is in your hand. You will simply update, because nobody will take care of development servers since it is a development environment. Customers are not worried about development servers. So usually we are very careless in dev environment. Okay, we will update, we will upgrade, we will install whatever we want. But production servers will be very careful. So mostly there is a chance of different OS versions across multiple environments. That is the major cause of working in development and not working in production. So, but here, everything we are maintaining a suit. Container and image, this is, you can say, immutable. This is a complete suit. Okay, so you will use same image in dev and same image in production. So there will be no scenario of working in development and not working in production. Okay, so that is the consistent environment across consistent consistent environment either in dev, QA and production. So this is the major point you can explain in the interviews. Okay, so they will ask what is containerization and why is it popular. You can say container or image is a suite of base OS, required packages, application server and application code. Bootable time is very less in containers and cost is also very less. There will be a proper resource utilization because containers will not block the server resources, and it gives high available nature, auto scaling nature. We can rely on containers, and it will maintain consistent environment because it's a container or image is immutable. We can shift the same image and containers to different environments, so that there will be no question of working in dev and not working in production. Okay, so this is how you can explain. And portable nature. Portable is same. I mean, I said right, working same image in dev environment, you will just move it into the production environment. So that is called portable. Portable is nothing but easy to shift. Okay, so this is the overall advantage of containerization. So this is why, because of these reasons, now it is very popular. Okay. So any questions till now, you can raise your hand. Because these are the basics, you should understand this properly. Just compare this anything with this film. Yes, Vikram.
Hey, hi Shiva.
Yeah, hi.
So the base OS is nothing but will it use the kernel level OS?
Base OS is what I mean. It's a bare minimum OS.
Okay.
Base OS is nothing but bare minimum OS. You know the size of windows. For example, if I open my task manager.
Okay.
Okay. So mine is 32 GB RAM. How much it is occupying? 34%.
34%.
So it is around 10 GB RAM.
Yeah.
If I close all these applications also, it will occupy 4 GB RAM.
Yeah. Okay.
Windows 11. Okay. Why? Because you have a lot of graphics running. Even you close every application, you will always have some background process running.
Correct.
We don't know what are those background
Yeah,
process.
yeah.
But application your server needs them to run your laptop or server.
Okay. Okay.
So bare minimum OS is very lightweight.
Okay.
Just to make your server running. So Windows OS is 4 GB usually. It will at least occupy 4 GB RAM. But there is another OS called Alpine. This itself is 5 MB.
Okay.
Equal to one MP3 song. Because why it is very less? Because they will not install unnecessary packages. They will not have graphics. Okay. So this Alpine OS is bare minimum to run your application. For example, in your laptop, you have VLC media player, you have browser, you have Google, you have very many unnecessary things installed. But in a server, what is the server intended for? It is to run an application, right?
Correct.
So base OS or bare minimum OS is nothing but
minimum capability to run that particular server.
Capability to run application.
Okay. Okay.
To run only application.
Understood. Okay.
So that is why I am calling it as base OS or bare minimum OS. So now you think on top of this 5 MB, if you install your application, then maximum it will come 150 MB.
Got it.
So 150 MB of your application, can you imagine how many instances you can run in a 64 GB RAM? Can run at least hundreds, right?
Correct.
So, but this is not possible with on-premise infrastructure.
Absolutely. Yeah.
So you need another server, another server, another server like that. So your application itself is 150 MB. That's it. You don't need to install another, because security wise also, if you have some unnecessary installations in your laptop, then someone can easily hack. So when it comes to container, there will be no unnecessary installations.
Got it. Okay.
So because of this much memory, because of this much less memory, we all have this kind of features: high availability, easy to scale, okay, reliability, and bootable time is very less, because the less memory, then boot up time is very less.
Very less.
You have more memory, the boot up time is very high.
Got it. Thank you, sure.
Yeah, most welcome. Any other questions? Yes, Parasuramadu.
Sorry, here non-bare metal is virtualization.
Yeah, this is bare metal. This is virtualization. Virtualization is, what is the meaning of virtualization is, you have a very big server, like a physical server. You are dividing that into multiple servers.
Yeah.
So this we call it as bare metal. So this we call it as virtual VM, virtual machines.
Virtual machines, sir.
Okay, so entire cloud concept is based on this VM only.
Okay.
So I am provisioning one instance here. So what is happening in the background? Amazon has a big data center like this. Okay, so they have very, very big servers like 100 GB RAM on 200 GB RAM or 1000 GB RAM servers. So out of that, they are creating one VM for us and they are providing to us.
Okay.
So you can see here to create a virtual instance.
One in EC2 instance is nothing but one VM, right?
Yes, exactly. So one EC2 instance is a one VM in a physical or bare metal server. Okay.
Okay. Non-bare metal means?
Non-bare metal means that's it. VM.
VM only.
Yeah, containers also non-bare metal. So
Okay.
bare metal is nothing but you should have a dedicated server for your application, then that is called bare metal.
Okay, sir, I understand.
Okay, so this entire cloud is based on the virtualization concept. Okay, so even this containerization also, you will create containers inside VMs only. Okay, so you are getting EC2 instance here. We will install Docker. So it means you are installing a containerization on top of one virtual machine. Okay.
Yeah. In one VM, I installed a Docker engine and working on Docker commands.
Yes, exactly.
Right. Thank you, sir.
Yeah. So just understand these points. If they ask about what is containerization, what do you understand from containerization? Anyhow, we will prove all these points while discussing on our project. So this is because of these many advantages. Now we have the microservices option, right? So earlier applications, we call it as like monolithic, or at least I can say. So in 2010, 2011, 2012, when I started my career, so we had something called ER files, Enterprise Archive. And we have WAR files, that is Web Archive. This is in Java. Okay. So here this will have UI, and then UI is nothing but HTML, CSS, and JavaScript. We had these are the front end technologies, and back end we have JSP and servlets. So these all things are packed as a single file. Okay, so this was around like just this code itself, it was around 200 MB. So what we were doing, we were taking one physical server, physical server, bare metal server, and inside this we were deploying this. So the problem with this is entire application is a single file. If you want a simple change also, you need to go for release. Okay. So sometimes customers, they don't feel the HTML, CSS is not good. They want more graphics inside this. Now they should change this. Because it's a single file, you need to go for a release, a big change. Even a small change is like a big change. You need to plan and release new version again. So here, instead of development, the release process is very tough. It can be a simple change of some color. Customers don't want some color, so they don't. They're not feeling good about a simple color in UI, so they want to change the color. To change the color also, developers should change in the code, build in development environment, deploy in development environment, again go for QA environment, again go for production environment, take the necessary approvals. Here the development is one day change, but deployment process is around a month. So that's why later what we got is monolithic. Monolithic is nothing but separate UI and separate backend. So that is called as API. So at least the maintenance is little bit good here. There will be a separate front-end team, and here there will be a separate backend team. So at least these two are connected with APIs. Okay. So usually they are JSON API or XML API. So now this can be deployed in separate server. This can be deployed in a separate server. Now at least maintenance is little bit decreased, because if you want a simple change in front end, you can only go for you don't need to touch this entire backend code. You can only release this one. Okay, so this is the monolithic. Still the backend is very high. For example, what are the disadvantages is, if you see Amazon.in here, okay, so if you see Amazon.in, so there is a cart, there is a product catalog, and there is a orders. So if you need a simple change in cart application, or if your cart is not working, a simple error that can cause this entire application go down. Okay, so the problem is a simple error in a cart can cause the entire application go down. Okay, so for example, we have a competitors, Amazon and Flipkart. Amazon following some microservices. Flipkart is not following microservices. So there is a simple error in cart application, then the entire Flipkart business is going down. But Amazon follows microservices architecture. So what is that microservices architecture? Is nothing but you will have front end, and back end is nothing but it's not a single project, it is multiple projects. User module is separate project, cart is separate project, catalog is separate project, payment is separate project, order management is separate project, and then order dispatch is separate project. So if there is an error inside the cart application or order application, your business will not go down. Customers can still browse the products. Okay, and it is very easy to restore a simple application instead of restoring a big application. Okay, so like this, it is very easy to restore a small application if there is an error, and the other applications, other modules, so these we can call them as modules, this will still work. Okay, this is a simple real life example. For example, you are assigning a task to a single person, a very big task, then it is very easy to track. Otherwise, instead of assigning a big task to a single person, what you can do is, create the subtasks and assign every one subtask to one person. So here, so then you can at least, if one person is doing something wrong, it is easy for you to correct, and parallelly other subtasks are also going in a right way. So this is more about the flexibility and maintenance. So if you see this microservices approach, flexibility and maintenance and business is not going down. So that is why everybody is going for microservices approach. If this is like 150 MB of memory here, or at least like 150 MB of code, so then it is 10 MB, this is 10 MB, this is 10 MB, this is 10 MB. So it is easy for you to maintain, to deploy, to release process, to restore the application when something is going wrong. So we have many advantages in a microservices approach. So just microservices are becoming popular. Similarly, containers also becoming very popular, because container is the best approach because of its bare minimum OS, high boot. Because of these advantages, container approach is perfect for microservices. Because if your application is very big like this, so this is like a old approach. Then you need a very big physical server. Okay, if your application is like monolithic, then you need a virtualization server. Your application is very small, you don't need a big OS. You don't need a many packages, because you need a bare minimum OS and some simple packages and simple application server. That is enough to run a simple code. So that is why containerization is becoming very popular nowadays, because of microservices approach. Okay, so earlier way of deployment was very tough. In this one, we had a nightmares, like we will announce the outage. Earlier, I think everyone, you feel this. Earlier days, whenever you go to the bank, they were saying server down, and they will announce some business outage. Okay, if you try to open online SBI at least 7-8 years back, so they will announce the downtime for 1 or 2 days. So in that 1 day time, what they were doing, they're deploying the new application. But nowadays you don't see any downtime because of the microservices approach. I never seen in last 2 or 3, 4 years, I never seen any bank is showing the downtime page. Okay, because everybody is following the microservices and containerization approach. So you no need to have any downtime. Your application can have zero downtime deployment process. Okay, so that is why we are learning containerization approach here. So in that, Docker is one of the software container engine suite to provide image and container capabilities. So what is the Docker architecture? What is container architecture? What is image? All these things we will slowly understand. First of all, let us create some containers and images. Let us install Docker and learn Docker commands. Create our own images and containers. So then we will understand Docker architecture. Okay. If I directly discuss the architecture right now, you may not understand, because you are not. If you practice all these things, then you will understand Docker architecture. Usually when I teach Java also, I don't want to discuss the Java history, Java features, and who invented Java, all those things. First, I want you to immediately write something. So then you feel like you are doing something practical. Once you write some programs, once you understand how Java is useful, how can you write programs, then if I discuss Java architecture, you will understand better. Similarly here, I don't want to discuss Docker architecture right now. I want you to understand how to install Docker, how to use Docker commands, how can you create your own Docker images and containers. Then if I discuss Docker architecture, you will understand better. Okay. So in today's session, we will install Docker. Okay. So installing Docker. So I'm taking the OS as AWS Linux 2. So this is same as CentOS. This is same as Red Hat Enterprise Linux, because companies mostly they use Red Hat Enterprise Linux or CentOS. Okay, so Amazon Linux 2 is exactly same as CentOS and Red Hat Enterprise Linux, because Red Hat Enterprise Linux is not a free, it's a paid version. Okay, so you can use CentOS or AWS Linux 2. So we will use AWS Linux 2 because it's a free trial in Amazon. So let us launch one instance. We have our EC2 instance ready, code. I'm commenting this. I'm commenting here. Okay. So you are launching one EC2 instance and you are creating a security group. Okay. And let us connect to this. Terraform init. Terraform plan. Terraform apply. So you can use PuTTY software to connect to the instance. You can use Git Bash. You can use MobXtream. You can basically use any SSH software. We got our instance ready. It is connect to this instance. SSH-I provisional pen EC2 user @ So you'll get a documentation how to install Docker in AWS Linux 2. We'll get official documentation from AWS. Okay, so these are the commands. Initializing. Sorry, here I didn't give the security groups. Go for Terraform apply auto group. Is terminating this and then creating another room. Okay, so this is the process anyhow. Update and then install Docker, start Docker. We can enable also. Let's wait for 1 more minute. Okay, you are inside the server. Now let us follow this approach. Yes. And then sudo service Docker start. You can enable it also. Sudo system ctl enable Docker. Okay, and then so this one. So whenever you install Docker, okay, install Docker. So what it does is will create a group called Docker. Okay. So you should add your user to Docker group to get access to Docker command. Okay. For example, if I run any, because I installed Docker, I started Docker, I enabled. Now, if you run Docker PS, you are getting permission denied because I'm running with EC2 user. EC2 user by default will not have access to the Docker. So for that purpose, you need to add your EC2 user to the Docker group. Now try again. Again, you will get, because whenever you do this, you need to log out of the server and then log in again. Now you run Docker PS command or some Docker command, you will not have the access denied. So this is the process of installing Docker in Amazon Linux 2, and almost same process either to install in CentOS or Ubuntu, whatever you take. Okay. So I will provide this documentation anyhow again. So now let us discuss some commands. Docker images command will show the images in your server. Okay. Docker images, because I just installed, I don't have any images. If you want to pull the image, Docker pull image name colon which version. So if you are pulling where the image is getting pulled, okay, so that is so in Linux server, if you install the packages, okay, I installed some package from where it is getting downloaded from some central server. Okay, so here even in your Windows, if you are downloading or installing any software, so it will be downloaded from central location. Similarly, the Docker will have something called as Docker Hub. Okay, so Docker Hub. So this is a central repository. So whenever you say pull, your Linux server will connect to this Docker server, Docker central repo, and then it will pull the image. So that is nothing but Docker Hub. So you can sign up to this hub.docker.com. You just register, like you register for GitHub, and then you can sign in. For example, I have tech world with Shiva something, and give your password. And then that's it. Okay, just like GitHub, it is a repository of images. GitHub is a repository of code. Docker Hub is a repository of images. You can create and store your own images, or you can download any public images. Now, if I pull Docker pull Nginx, then it will pull from the Docker Hub because it is not available here. If you just search here Nginx, you can see there is an official Nginx image. It is from Nginx company. Here there will be a tags. Tags is nothing but version. If you don't give any version while pulling, then automatically it will pull the latest version. If you give some version like this, table something, and then this is the version, then it will download that version. For example, now I'm not giving anything. Then you can see it is by default pulling the latest version. Now, if you say Docker images, it will show you have the Nginx image of latest version. You can give any other version, colon, can take anything. For example, now I want to download this one, or there will be Alpine version. Let us search here, Alpine. Okay, this one, take this. Now use Docker images. Now you can see this Nginx is 11.5 MB. This one is 187 MB because I said Alpine is bare minimum OS. So what is this Nginx image? So inside, for example, let us take this one, Alpine. So it has Alpine OS, some packages, and then Nginx server. Okay. So usually what we do, we will take this OS as base OS, Nginx, this version as base OS, and on top of this, you will copy your application code. Then that's it. Run this, you will get your app up and running. Okay. So this is how you pull the images. And so you have image now. How can you create container? Create container from image. So there is a simple difference between image versus container. Container is a running version of image. Okay, so image is a static file. For example, if I tell you to download OS, then you will download the OS. The OS will have Windows and all the necessary package to run a laptop. Okay, so but when it is called as running version, if you install that OS into a laptop, then it is called as the running version. Similarly, image is a static file. It has all these things, bare minimum OS, packages, and server and application code, whatever you can keep it inside. It's a static file. But if you run it, then it will be called as container. Okay. So someone if ask what is image versus container, then you can simply say container is the running instance of the image. Now how to create container out of image is Docker create and then image ID. What is the image ID here? For example, this one. Okay. Docker images command and Docker pull command image colon version Docker create and then image ID will create container. Okay. Running containers, how can you check? That is using Docker PS. Now, if you see Docker PS, then there will be no running containers. But if you give -a, it means all. Then you can see a container is created, but it is not running. It is in created state. Docker PS -a will give all containers, includes not running. Okay. How can you start the container is nothing but Docker start and then container ID. Now, if you do Docker PS, you can see your container is up and running. Okay. Docker start container ID is to run a created container. Okay. So there will be a single command that is Docker run and image version. This is equal to Docker pull plus Docker create and then Docker start. So instead of running all these commands individually, you can run a single command that is Docker run that can do all these things in the background. Now let us see how to stop it. Docker stop, then this container. Okay. Now there will be no containers and this one. Okay. How to remove the container is nothing but Docker rm and then container ID. Okay, there will be nothing, no containers. And now how to remove the images? Docker rmi means remove image, and then you can give your image ID. Now another image. Now you can see I don't have any images. I don't have any containers either running or created. Now I will run a command Docker run nginx latest. Now you can see what will happen. It is not able to find the image locally. So it is downloading from Docker Hub. First it is pulling and then it's downloaded. And after that, this entire process is creating the container and then running it. Okay. Now you can see this is in foreground. If you come out, you will press Control C. Then you check Docker PS. It is exited because by default container will run in the foreground. If you want to send it into a background, Docker run -d. It's a detached mode, nginx, and then latest. Now you can see Docker PS, it is running in background. Okay, so that is the detached mode. So you know how to stop, Docker rm, Docker rmi. Now I want to assign a port. So this is your server. you have your container running, Nginx container. How can you access this Nginx from outside world? Okay, so remember this point. Every server has few ports, 65,535 ports. Okay, and container also has same number of ports, 0 to 65,535 ports. But by default, container ports are not exposed. Okay, so in that case, what we will do is we will have a port. So this is the called as host port, and we will have a container port. So we will attach these two. And users from outside world, they will hit this container port. The traffic will be automatically routed to the host port. So I will show you practically. Let me remove this Docker rm. It is running. You need to apply some force. Okay. So now what I want to do is Docker run -d in detached mode and -p. It is for port. First port is host port. I want host port 80. And then by default, you know, Nginx runs on port number 80. I am mapping host port 80 to the container port. So how do you know Nginx running is on port number 80 is from the documentation? These are some default things. Okay. So Nginx runs on port number 80, and then Nginx runs on Tomcat runs on port number 8080. Okay. You should know this information generally. They will provide this in documentation. You can see port number 80. Okay, so now what I do here, this port number 80 is mandatory. You should refer from the documentation. Host port, you can allocate anything. Now, if you run like this, okay, now you access our server on port number 80. See, you can see the traffic is forwarding to the Nginx container. So what is happening? Here, this is the host port. You are hitting the IP address of this server with host port 80, then the traffic is being redirected to the container. So you have a single container. You can create any number of containers. For example, I want to create another container on port number 8080, another container on port number 8081. Okay. Now you can see here on 8080, you have, sorry, on 8080, you have one container running. On 8081 also you have another container running. So you have total 3 Nginx servers are running here. Okay, so this is how you can allocate the ports to the container. Now I want to log in inside the container, just like you are logging inside the server, right? I'm logging inside the server using SSH. Similarly, I want to log in inside the container. So the command is docker exec. Exec means execute. IT means interactive terminal. Okay, interactive terminal, and then your container ID and bash. Okay, now I'm inside the container. So here usually we will have the etc nginx. Sorry, what is the HTML directory of nginx? Where www, no. HTML directory of Nginx. Configuration. I forgot this. User share Nginx HTML. User share Nginx HTML. Okay, here I will create something. Hello Docker from 8081 port into some hello.html. Okay, so I log in inside the container. Okay, this one running on port number 8081, and I created some HTML file. Okay, you can see here slash hello.html if you type. So you are getting the response. Okay. So we can stop till here today, and we'll continue in tomorrow's session. Any doubts? So all of you can just randomly view some videos of Docker. I listen to the recording, whatever we discussed again, understand the advantages of containerization in terms of these things, and try to create easy to instance and install Docker, run these commands. Tomorrow we can have a small recap again and we can start. Rajasekhar?
Just a small query regarding the port numbers. Just if we give 80 port, it will be running on HTTP, right?
Yeah.
So what if we configure host port as 443? Will it be running as HTTPS?
No. You can still do it. So to come out of this, just exit. The system ports, sometimes they will run or not. So now it's not HTTPS. Until you configure, it's not HTTPS. For example. Okay, now you can see.
It is working, yeah. But
still, if you configure HTTPS only, then you can. Otherwise,
okay,
it will still work on whatever the port you give.
HTTP only. Okay.
Yeah. Kumar? You have some question? Kumar? Parashram, do you still have some question?
Sir, is there any Docker life cycle?
Docker life cycle, we will think when we will discuss when we are discussing when we discuss Docker architecture. See, life cycle is nothing but born and die. What is the human life cycle? You born and then you die. Similarly, Docker life cycle is nothing but when your container is running, it is living. When your container is exited, then it is done.
Okay.
Okay, we'll discuss that later. Too early to discuss.
Okay.
Yeah.
Hello.
Kumar? Yeah.
Hi Shiva.
Yeah. Hi.
So we are fetching image from Docker Hub, right? So
Yeah.
so just we are fetching Nginx, right? So it's taking the base OS of our CentOS, right?
No, base OS is inside the image. Okay.
So
you can set up any base OS. It's inside the image.
So Nginx itself creates an image. What is that? I can't understand.
Nginx is nothing but here I mentioned, right? Where is this? So this is nothing but Alpine OS.
Okay.
plus some packages and Nginx. So you'll understand when we create our own image.
Okay. Fine. So it's a package of all those things.
Yes, it's a package of everything.
Okay. Fine. Thank you.
Yeah, you're welcome. It's nothing but our Windows OS is also called as ISO format. Whenever you do some Windows OS, it's a single file of .iso format. You can call that as image. It means it has the OS and some necessary packages of browser. You will have this Internet, Microsoft Edge. These are some
Yes.
required packages, right?
Dependency.
So that, yeah. So it's Windows OS is not just a Windows OS. You have many utility packages like Notepad. You will have sometimes MS Office if you pay for it.
Yes.
Okay. So you have some Windows Media Player. You have some PDF installed. So all those things are OS plus required packages. Similarly, Nginx is also a bare minimum OS. There can be many flavors. You can have Alpine, you can have Ubuntu, you can have Debian, whatever.
Okay.
Okay. So you'll understand when we create our own images. So in this session, we are downloading the images from Docker Hub and then we are using it. In our next session, we will create our own images. Okay. Yeah, Samba Siva.
Hear me?
Hello. Yes.
Hi Shiva, one question.
Yeah.
Does microservices follow the three-tier architecture style, or
Yes,
they use
yes.
only API?
Yeah, it follows the three-tier architecture. So microservice is in the API layer. Okay, you will have
Okay.
one application of front end. You have one container, front end container. You have one back end container, and you can have database container also.
Okay.
Okay.
Thanks.
Most welcome. So you will get this clarity when we complete 2 or 3 sessions. So in this session, maybe just concentrate on how to install Docker and what are these advantages of Docker containerization and how to use Docker commands. Okay. So I'm sure definitely first 1 or 2 sessions, you will not understand completely. Maybe you'll understand 50 to 60%, but just practice, trust me. And from 3rd session, you will get full clarity. And from tomorrow itself, you will get full clarity. Okay. Sai Krishna.
Hello. Hi,
Yeah.
Shiv.
Hi.
Can you explain that -d detached mode once?
So -d is if you don't use -t, then it will run in the foreground.
For
Cannot do anything. For example, if I give something like this, it is running in the foreground. You cannot do anything. It is stick to the terminal. So that's why we are sending it inside the. We are sending it to the background.
okay.
Okay.
Okay. Thank you.
Yeah. So I hope you answered and you got some clarity. Yeah.
At what scenarios we can take Alpine image and normal image usually?
If you want very less memory, you can go for Alpine image.
Okay. Okay, that's it, right? Okay.
So Alpine has some disadvantages. You will not get everything right.
Okay.
So usually, and it's not secure also. You need to provide your own security. But this CentOS and then Red Hat Enterprise Linux, they come with some security features.
In real time, which OS or which one recommend?
In real time, generally CentOS, Debian, Alpine also preferred. Okay, if you are able to have your security team, like network security, if you have some team, then go for Alpine also, not a problem. So actually in the containers, OS doesn't matter.
Okay.
Okay, OS doesn't matter at all.
Mm-hmm.
User, they don't know which OS the application is coming from. The application will directly work. We will see that anyhow.
Oh. Yes. Thank you.
So as an application person, usually developers, you should never worry about the underlying OS. As a developer, I want my application should be up and running so that the customers can access the application. I'm never worried about the OS. So that is the problem in olden days. So we were more worried about the OS. So there is a dedicated OS team, so solving the problems, administration team. Now we don't require all those persons. You can directly configure your application up and running within minutes.
Okay. Okay.
Yeah, so you'll get full clarity in tomorrow's session. For now, just install Docker in EC2 instance and practice Docker commands. Then we will see the next class tomorrow. Okay. Have a nice day. Good night. See you in tomorrow's session.